Electrical Energy Measurement Part 7. Three-phase power measurement, the two-wattmeter method. The universal method. The two-wattmeter method is the most widely used technique for measuring power in a three-phase system. Unlike the one-wattmeter method, this technique works for both star, Y, and delta, \delta, loads, and crucially, for both balanced and unbalanced conditions, without needing access to the neutral point. How it's connected? We use two separate electrodynamic wattmeters, W_1 and W_2. Current coils, CC is connected in series in any two of the three lines, e.g., line A and line C. Pressure coils, PCs, each PC is connected between its respective line, A or C, and the remaining third line, line B, which acts as the common reference point. What W_1 and W_2 measure? Each wattmeter measures the instantaneous product of the current through its CC and the voltage across its PC. W_1 measures V_AB *I_A with phase shift included. W_2 measures V_CB *I_C with phase shift included. Total power derivation. The power flowing into a three-phase, three-wire system must equal the power measured by the two wattmeters. It can be mathematically proven that the total active power, P_T, is the algebraic sum of the two readings. P_T is equal to W1 plus W2. Calculating power factor, balanced loads only. This method allows us to calculate the power factor, PF, but only when the load is balanced. The two wattmeter readings are used to find the power factor angle, \phi. Tangent of the angle tan phi, is equal to square root W2, W1 plus W2. Once phi is found, the power factor is simply cos. Significance of readings and power factor. The relationship between W_1 and W_2 directly indicates the load's power factor. Relationship power factor, cos, load type. W_1 is equal to W_2, 1.0, unity, purely resistive. W_2 is equal to 0, 0.5, lagging leading, RL or RC load. The negative reading. If the power factor is less than 0.5, one of the wattmeters, W_1 or W_2, will display a negative reading. To physically read a negative value on an analog meter, you must reverse the connections of that meter's current or pressure coil, and then subtract that reading in the final calculation. P_T is equal to W_2, vertical bar W_1 vertical bar. Calculating reactive power, Q_T. The two readings can also be used to find the total reactive power, Q_T, consumed by the system. Q_T is equal to square root W2, W1. Transition to energy. We have mastered measuring instantaneous and average power, P, using wattmeters. But power is just the rate of consumption. To measure what really matters, the energy you pay for, we need to integrate that power over time. Next, we introduce the device that does exactly that, the energy meter.